Right. So, yeah, conference was announced, and I wanted to talk a little bit about authentication and authorization microservice systems, because this is something that I've managed to encounter quite a lot in the past couple of years. And that sounded like a cool title, and I started writing my slides and putting together my thoughts, and then realized, yeah, this is way too much to discuss in a half-an-hour presentation. So I did authorization, and I'm only going to talk about end-user authentication in microservice systems. So that's final title. That's me. Probably most of you actually know me. I'm with OpenCredo since 2013. Those are my contact details. And I actually managed to work in microservice systems ever since I joined the company. And I actually managed to deal with authentication problems in every single one of them in the past 2.5 years or so. So this presentation is a little bit about kind of try to distill the experiences that I had with this topic and the problems that I've ended up facing, and just the challenges that kind of should be considered or needs to be considered. So first thing, why do we care about authentication in microservices? And by the way, just to set a baseline here, authentication is about establishing the other party's identity, and that's all I'm going to talk about in the next half hour or so, because as it turns out, it's not that simple. So why the problem is, and why specifically with microservices, and why do we need to care about this more in microservices than before? Well, traditional system looked like something like this. You had your application, talk to a database which contained your users, you logged in your users, everything was happy. There's nothing really problematic. Typically, I was working in my career, I've been working with web applications, so there was a HTTP session going on between your application and the users. You established who the other party is at the beginning of the session, and then you just relied on that. State was stored on the server side. Things were good. You might have had 2 instances of this application running for resilience purposes. They shared the user database with a load balancer in front of it, which you configure to do sticky sessions, so your users ended up talking of one of the instances, not a problem. Or in an enterprise world, might have integrated with a single sign-on solution, again, keeping with the same type of, fundamentally same type of behavior than before. Fairly simple. Now, microservices come along, and your system architecture started to look like, all right, microservices come along, and we like microservices for a bunch of reasons. They're small, easier to keep in your head than your big monolithic application. You can scale them up and down independently. You localize your failures. You can scale them independently. The downside is that your functionality will emerge as a composition of the services, and the tendency is that users tend to access more than one service at a given time. Also, as a kind of a result of these characteristics or these goals that we want our microservices to achieve, started to do things like we prefer totally stateless architecture, stateless user communication. We tend to not relying on HTTP sessions that much. And we also deploy into, again, this is not necessarily a prerequisite for a microservice architecture, but the tendency is we generally tend to deploy to Kubernetes, Mesos, Cloud Foundry, which sort of takes away some of the control of your application instances or service instances. They can just kill them whenever they want to. They move over services or servers or whatever. You have to just do a mental shift and start not relying on state stored in the service instances, because it might not be there next time the user accesses that. And the architecture kind of looks like that. Hopefully, when you actually build something, it's a little bit more structured than that pile of services there, but you get the idea. You go to your users, they talk to some of the services, then they might talk to others. And the users should be completely unaware of what's going on in the background. That's very important. You don't really want to expose your implementation details to users. They should be they should not know whether they are talking to another service on another instance of the same service. It should be hidden away from them. Let's drop in the same type of architectural pattern that we had before. Let's our services talk to a shared user database. That has many problems, like the microservices don't like the shared data models because like who owns that data model at this point? Also, scalability-wise, it's not really great. You have a pretty bad single point of failure in the user database. So obviously, that needs to do something about that. That's just not going to work. Right. So shared user database, bad thing. Microservice anti-pattern, not scale, doesn't scale. Single point of failure, no. They're distributed. Let's distribute our user data. So instead of having a single shared user database, we just drop a bit of user information into any microservice that is concerned with that. It's cool. That's every service should own its own database, its own bounded context containing all the entities that it's interested in. Users are one of those. Okay, sounds good. Users, you probably want to identify or authenticate them or identify them with some sort of credentials. Which one of these guys is going to own the credentials then? Well, single responsibility principle. If I have a problem that I want to authenticate my users, best thing probably to do is to create an authentication service that is responsible for authenticating our users and owning the credentials of the users, and generally just managing, yes, can this user log in? Can I establish who this user is? Don't spread the responsibility around, spread some of the aspects of the data around that you need. So yeah, that's cool. And problem 3 is what I'm going to spend most of the rest of my talk talking about is what happens when you switch a service, right? So let's say your user is accessing, I don't know, like your web shop application. Let's assume user is accessing some, I don't know, wants to buy a new mouse for his PC or whatever. So it's browsing his web shop in the My section. That's probably one of your microservices. User wants to then change his email address or delivery address, which might be served by another service. So clicks into the top right corner on his name and then hops over to the other service, which is responsible for dealing with the user's own, I don't know, delivery information. That should be a seamless transition from a user's perspective, but we need to do something with our services so that the user doesn't know that he's been jumped over to another service. So yeah, we could authenticate the user every single time this happens. That's obviously not a good idea to do because it will be a pretty crappy user experience if we did that. So what do we actually want from this? How do we want a system like this to work? We want it to be secure. Security meaning that the users are securely identified, and the sharing of information about within our microservices could be a concern, depending on how we actually deploy this system. That's something just to keep in mind that, right, do we share secrets between our microservices? What secrets do we share between services and the users? Ideally, we want stateless services with multiple instances running because we are deploying in the cloud. Anything can fail at any time. So we design for failure. Statelessness helps in that a lot because we don't have to worry about, oh, this instance has gone away. What do we do now? There is another one, and it should be just able to do its job without any hiccups. Same thing, no single point of failure. Like the shared user database, my biggest problem with that was, yes, there is a big single point of failure there. Ideally, if any one of your services in your world suffer a catastrophic problem and all the instances just die suddenly, or any of your data persistence infrastructure goes away, it should be a localized failure in that part of the system, and ideally it shouldn't affect any other components, and the user's perspective, the user experience might deteriorate or might not be able to access some parts of the system, but the rest should ideally work as before. So that's what we want, and we'll see how far we can get with it. Performance bottlenecks, again, one of the drivers moving to microservice world is that we can scale stuff on demand easily and independently the individual services. If for the authentication purposes we put in something that's preventing that or something that has to participate in every single user interaction, that could be a problem. And again, we want this to be transparent. We potentially want the ability for the users to log out. This is not something that often considered, but think about it. When you click on log out in any of the web shops or whatever that you use, you kind of expect that you are logged out properly, as in you cannot do any weird hacks on your computer that would restore your authenticated session. So let's aim for ability to log out. We might, depending on your actual needs and the actual system that you implement, you might relax that requirement a little bit. That is one of the points. Logout is actually more complicated to do in general terms than logging in weirdly. It's one of those things that we really had problems with on projects before, and it's generally seemed to be an afterthought. Oh, right, we logged in now. Do we want logout? How do we implement that? It's actually a problem. And we want nice integration and simplicity to implement it, obviously, because we are developers and inherently lazy. So 4 options that I could come up with, and actually ended up using most of this in some form, one way or in the other in the past, is to use some sort of single sign-on solution, extend it into the microservice world, use a distributed session, or use client-side tokens, potentially with an API gateway, and I'm going to walk through each and every one of these in detail. How much time do I have? That's cool. Okay. So I've got time to talk about all these. So right, first thing, using SSO. Right, we got single sign-on software. They've been around in the enterprise world for a while now. And they do exactly that. You have 2 different applications. You logged into the central SSO server. Let's log into the other one. Or let's log into my applications independently. Short detour of most of these, and I'm going to put up a diagram here about the CAS server, which is the JASIC Central Authentication Server, which is a Java-based open source thing that we ended up using in the past. That works in this way, but OpenID and OAuth 2 are actually pretty similar if you look at the actual interactions going on between your authentication server, your user, and your application. So standard SSO or a standard way of single sign-on works in a way that, right, my user wants to access my application. User is not logged in. Let's log into the user. Oh, I've got a single sign-on server. Let's tell the user, hey, user, go to the single sign-on server and prove yourself. User then goes to the single sign-on server. Either this one understands that the user has already logged in, or so somehow the single sign-on server makes sure that the user is logged in, authenticated, asks for credentials, whatever, then redirects it back to the application, which then in the background checks, right, the user presented me some token of some sort. Is it really from you? Single sign-on server then says yes. And this is the user that presented you that token. Here are all the details that you need to know about this user. Cool. So as I said, the authentication server or the SSO server maintains a global login state. And actually most implementations kind of rely on HTTP sessions in the application level. So you don't really, because of this whole flow, when you log in a user to a server, you then do this redirect back, background checks, everything. It's quite a lot to do on every single HTTP request. You can do it, you probably don't want it, so you cache some locally maintained login state into the HTTP session of each of your applications participating SSO. Right, so you create your single sign-on server. This is how your architecture now looks like. It doesn't look very nice, does it? So your single sign-on server is your single point of failure at this point, because every single microservice needs to be able to talk to it. However, because of the local caching that tends to be the case, you actually only end up talking to the SSO server the first time you interact with a new instance of one of your services. So that's kind of all right. If your SSO server goes down, probably the impact will be you cannot switch to another service, which is, there is a single point of failure, but it's not that bad. Chatty traffic, it can be quite chatty because of the redirection back and forth to the SSO server and your application. And then talk about local login caching. Cool. But chattiness is not a good thing. Right. So how does it line up with all of our criteria? So security-wise, depends on our single sign-on implementation. Generally speaking, the user is not aware of this interaction, and any tokens that the SSO server sends to the application through the user's way, all of our sessions, all of our state that is stored in the user state is completely opaque. That's true for most implementations. It's pretty hard to infer any information from just the tokens that are visible for the user. There is no particular secret sharing between the services, so we're good on that side. The applications needs to understand where the SSO server is and needs to trust that, okay, that is the genuine SSO server and not some fake thing. But because you control all your network on the server side and all your deployments, it's usually all right. Statelessness, pretty bad. We tend to rely on HTTP sessions, which goes against our stateless nature of the architecture that we are aiming for. So that's a no. And the authentication server can be a single point of failure and a bottleneck, but it generally only manifests itself when you are switching services. So it's not great, but it's not the end of the world. Transparent from the user's perspective, yes. Logout is a terrible, terrible nightmare in this world. It's very bad because both your SSO server and all your microservices end up holding user logged in state. When you log out, if you want an enforced logout, you have to clear that state across everything individually. So the ways that generally tend to implement this is either you just send the user around when clicks logout, you just visit every single instance of services that he ever visited and log out from there, which is bad, painful, or you do some sort of message broadcasting on the server side that tells you, okay, user is logged out, now everybody logs out this user. But that, if there are failures with that, it is hard to enforce logout. The technologies that are out there, CAS and some variations of OAuth 2. Now, OAuth 2 is OAuth 2 is an interesting thing. It's supposed to be an authorization protocol, but it's easy to bastardize it and use it for authentication. In fact, if you encounter something called OpenID Connect, it's exactly that. It's an authentication layer over OAuth 2. It's a very complicated and very vague RFC, but it tends to come up when people talk about single sign-on. Integration-wise, you pretty much get servers and libraries to integrate. They're reasonably good, but it's not trivial to implement, especially if you consider stateless nature of things or logout. You will end up configuring your load balancer for sticky session, and again, logout we talked about a lot. So that's a very... So yeah, SSO does work. It can be problematic, but it's all right. Distributed sessions, number 2. Right, so just how this looks like. You have your authentication server and your microservices, and both of them talk to a background store that is just a big distributed hash map. Really, it should be as dumb as possible. And you're actually extending your HTTP session across multiple application instances. You're ripping out your HTTP session, which tends to sit in the memory, and putting it into a distributed data store. So when the user wants to log in, the authentication server logs in the user, writes okay, this user has been logged in, cool, into the session store, and sends back some sort of session ID to the user agent, or the sets a HTTP cookie, something along those lines. And then every single microservice can just access the distributed session store and check whether the user is logged in or not. Usually you set some TTL on it, so this session will expire after some time. So yeah, that's about it. It's actually fairly simple on principle, a lot simpler than having a SSO server running around. In terms of how does it line up to our criteria? So security-wise, we're pretty good. We're not sharing any information whatsoever to the user. We have this opaque session ID. Doesn't mean anything. We can rotate it whenever we want to, pretty much. That's cool. Very difficult to infer any information on the client side from what you can see there. Sharing of secrets or sharing of stuff in the server side, everybody needs to be able to access this session store, which can be a problem depending on where you're deploying, but again, it's hard to tell up front. Statelessness, there is a shared state in the server side, but the users talking to our services do not have any state. So you can go to any instance of any service, they will see the exact same thing, and you don't have to worry about that too much. A bottleneck and single point of failure. Yes, everybody needs to talk to your session store. However, the technologies underpinning this is the dreamland of any distributed key value store, because you got individually totally unrelated items of data that are just a big blob or something. So Redis, Cassandra, Hazel, Castriac, all of them will do the job properly. So yes, theoretically, the session store can be either of those, but the technology is underpinning that usually give you pretty good support to not to actually have those as a problem. Transparent from the user perspective, yes. Logout, yay, finally that's something that's easy. You just delete the session or set a flag that this user has been logged out. Boom, you logged out from everywhere. So that's really cool. Thing is, you probably have to end up rolling out your own solution for this, because you just have to plug it in. And actually, Hazelcast might have some HTTP session that you can plug in a Java server, but I'm not really aware of anything going on there. Client-side tokens. Now it's getting interesting. So far, we've been storing state on the server side, and every important information has been on the server side, but you can actually give it to the client side. So in this case, there is no direct relationship between the service and the authentication server. So you just say, hey, I want to access a resource. You're not authenticated, go to the authentication server and authenticate yourself. It happens. Auth server sets an ID token on the user side, which in itself is a self-contained package of information describing the user that is securely containing this information. This security typically means some sort of cryptographic signature, which means that only the authentication server can possibly have produced that token. So the services then can reliably consume that information. So the ID token contains a user ID and a signature at the bare minimum to make this work. And when the service wants to use it, it just checks the signature and a TTL, and yeah, that's enough. Little detour. What we ended up using in our latest engagement is the JSON Web Tokens, which JWT, or some people say it as JOT, seems to be the de facto standard for doing client-side ID tokens nowadays. There is a lot of library support for this out there. You just go to jwt.io and you will see like 100 libraries supporting this and all sorts of stuff. What it is basically just a standard of structuring these ID tokens in a JSON format. It's got a header, a body, and a signature. Base64 separated with dots, and then you can chuck it in a HTTP header or a HTTP cookie or whatever you prefer to use for this. Header describes, this is how I signed it, this is my user ID, and whatever any additional information you want there, and then there is a cryptographic signature at the end of it. It's pretty simple. It's extensible. There is a couple of standard items you need to put there or can put there, but you can pretty much just put whatever you want, whatever information makes sense for your use case. Importantly, you can do a private key signature or a public key signature. Public key signature is interesting because you don't have to share that signing secret across your services. You just publish. The authentication server just publishes its public key, and you can use that to check the signatures. JWT.io for more information. Token is valid until a TTL set on it. and the microservices, they just accept it without any checking whatsoever. You don't talk to the authentication service, hey, here is a token, is this good or not? So how do you really log out with this? The answer is that either you just don't and you revoke the tokens on the client side, you use short TTLs, and you don't care. That could be a valid answer. Or you can do a PKI CRR style revocation, so each service would maintain a list of revoked tokens, and you would distribute this revocation list to all your services from the authentication service when a logout happens. This can be really tedious to implement, and again, the reliability of that is a problem. So logout, purely using client-side tokens, logout is an issue. If you consider you doing this, bear that in mind, and bear that in mind when you start implementing it. Okay. So how does it line up for our criteria? Security-wise, we are potentially exposing user IDs. Even if we encrypt that token with a proper symmetric encryption, we're still putting that in the client side. So that's not great. Secret sharing, if we are using public-private key signatures, that's good, because we don't have to use, we just have to share the public key of the authentication server. We are completely stateless. We don't have any single point of failures or bottlenecks, because the individual requests just go to the, so you don't need to talk to anything else when microservice wants to get user identity. We are transparent. We got technology support, so JWT, and actually OpenID Connect is a protocol that has it's a layer over OAuth 2, and it has understanding over user identity a little bit better than OAuth itself. But JWT and this and has very good library supports. It's actually super simple to implement. Yeah, if you want to log out, then think about how is it going to work. It can be problematic. The fourth one, very quickly, because I don't have much time, just client-side tokens plus an API gateway. That is an improvement over what the client-side tokens do. The idea is that you front all your communication with a gateway that translates these ID tokens into an opaque session ID-like token, writes it into some sort of key value store to look it up. So your services don't change at all. You just have this API gateway in the front of them. It's fairly simple. It solves your problems about exposing the user identity into the client side, and it solves your problem about logout, because you just wipe the tokens or revoke the tokens from the API gateway store, and that can enforce a proper logout. So it's actually checks most of our boxes. Implementation-wise, this is going to add a bit more complexity, because you have to put that API gateway there, and it has to understand your token structure as well. So to summarize, this is all those tables put together. I'm not going to go through this again, because there is a lot of ticks in there. Any questions? That's my contact details. Question? Yeah. Right, so the question was, is there anything that I would recommend out of these solutions, or is it depend on the context? If it's completely greenfield application, it's a new microservice system that is declared to be a microservice system that you are developing, and then you have to worry about authentication, I would go with a JWT solution to start with, because it's easy to get started with. It is actually, I think it's superior to a pure SSO solution. And you can extend it to the API gateway world later on without changing your services. That's very important, that with these two setups, you can your services understand the JWTs, but if you put something in front of them that translates those, they're completely unaware of that, and you can just drop that in later on. Don't go down the JWT single route if logout is important. So if you are doing like a bank system that gives access people to your money, I wouldn't do that because logout can be a pain to implement. Also, if you are having like a web shop type of thing, when you have your shopping basket, that's a distributed session type of thing. So you might have those technologies readily around. So I might consider doing that if that is the use case. What? Sorry? Yep. Mm-hmm. So the question was about inactivity timeout. So if you are inactive, your session expires effectively. If you go with a JWT sort of approach, then your JWT expires usually pretty quickly. So unless you explicitly renew it, and you can code against what renewal policies do you want to allow for, it will just expire if you don't reset it. So that's there. Again, a distributed session, you can set the latest activity time on that session and expire it afterwards. SSO solutions tend to be a little bit trickier than that because they operate with multiple timeouts. So your single sign-on session might time out a lot, like typically like 8 or 10 hours even, like for a full day, while your individual applications tend to time out much quicker. So that's, yeah, that can be tricky. And API gateway, you probably have some sort of store again, which you can register the last usage time and expire it based on that. Any, Miles? Mm-hmm. So the question was cross-domain considerations for JWTs. No, I haven't. So the only JWTs actually I started using on the current project, which doesn't have this problem. Actually, it has an API gateway in front of them, although that API gateway doesn't deal with authentication-related concerns at all, but that hides away any cross-domain considerations. Additionally, the JWT on its own doesn't know about domains, doesn't care about domains really. It's a self-contained piece of string, effectively. So the fact that your browser might refuse to send it cross-domain, that's kind of an implementation concern on the client side. So if you have a rich web application that pulls information from multiple domains, then it has to understand, oh, there is a JWT here, and just distribute it across the domains. You probably can't use HTTP cookies in that case out of the box. But you can code around that in the client side. There's nothing on the server side that would prevent JWTs from being used that way. Yeah. Okay, anybody else? Thank you.